This will be one of our review videos of Chapter 6 for Math 105. So we'll move it up and we'll take a look at example 1. Now, I'll stress throughout these is we want to develop a strategy for ending up with the correct answer. And part of it is, what do they want you to do? Well, for something like number 1 here, what they want you to do is to multiply. But before you multiply, they want you to simplify. And we simplify by seeing if we could factor something here. So with that in mind, let me set it up for you. So in this first factor over here, this is simplified. But in this one, you see I can take out a 2 from each term, which is what I did, and I ended up with this. And this one was a two-stage process in which we factored out a 3 first, and then here we see the difference of perfect squares that will factor into their conjugates. Now your next step is to see where can I cancel out. In fact, let me get rid of this one over here so it doesn't confuse you. That was an intermediate step to get to this. Well, this will cancel with this. This will cancel with this. So in our numerator here, we're left with a 2. And in our denominator, we're left with 3 times y minus 5. And you might say, well, should I distribute that 3? And the answer is no. Leave it in the factored form. So you have simplified number 1 through canceling out common factors, and there is your answer. Now, if you did multiply this through, that would still be correct. All right, let's look at number 2 for a moment now. An interesting thing is going on here. Above this blue line, this is the sum of perfect cubes. Now, the sum of perfect cubes will factor, and we'll show that here shortly. This is the difference of perfect squares, and this will factor into its conjugates. Now, since this is division, we're going to have to put this term on the bottom, this term on the top, and change it to multiplication. So that's the key here. And then these are just factored. So let me do the factoring and I'll get back. Now, as we look at the sum of perfect cubes, this is from section 5.7 in a previous lesson. We take the cube root of that and the cube root of that. That gives us this factor. And the sign that's there is there. Then the middle sign over here is the opposite of this sign. That was part of the recipe of factoring the sum of cubes. And then you squared this term, multiply these together, you got your 2x. The sign is determined by the opposite sign of this. And then squaring the last term gives you this. Okay, then the conjugates of this difference of perfect squares are these. Now, this was division. We had to change it to multiplication. When we did that, we had to flip this, that is, take the reciprocal of this. So this factored in the denominator is this, and this factored in the numerator is that. So the simple, well, not simple, but challenging division of polynomials gets to be this. Now, what do you do? Well, you start canceling out common factors, just like we did up here. Oh, did the wrong one here. Not this one. This was x minus 4. Okay. So what are you left with then? Well, everything is canceled out, and these are all ones except this. So we have this over this, and that would go in your answer column here. All right, looking at number 3, it says find the least common multiple of these two polynomials. Well, the strategy is to factor them. That'll be for this one. And this will be for this one. Now there's no common factors. They're in standard form. So we're just going to factor these. So this is going to be 4 and 3. Both will be plus, and if we FOIL, it gets back to this. And here we have x and x. 7 times 4. The 7 needs to be negative, and this one will be positive. Now, to figure out the least common multiple, we're going to use the strategy. What's the greatest number of times a factor is used in any one factorization? Well, as we look at our x plus 3, that's used once here, so we're going to need one of those. X plus 4 is used once here in this factorization, and once here in this factorization. So we're going to need one of them. We don't need the both because they're only used once, and this is just used once. So our least common multiple are these three that I've underlined in red. All right, I'm leaving this work up. By the way, the strategy would be to, before we do a problem, you can pause the tape, try it yourself, and then see if you get these answers. That's another strategy. Okay, here we have two fractions, and the rule for adding fractions, there must be the same common denominator, which they have. So all you do then is add your numerators, and I'll put that in standard form, x squared plus 4x. We're just adding these. Now on the top here, you could factor out an x, but nothing cancels out, so that basically is your answer. All right, we'll raise it up and continue. Now, as we look at example 5, and we say, are they common denominators here? Well, this is A minus B. This is B minus A. So no, they're not common, but we can make them common, and that's what we need to do. Now, a technique that we had mentioned in an earlier section was that when the signs are sort of like opposite, we can reverse those signs by taking out a -1. So I'm going to take out a -1 here. That makes this B a negative and this A positive. So now they're the same. And remember, we said we could also, if this is a plus, we can make this whole term, because of this division bar acting as a grouping symbol, this a negative. Now notice what happens. You have a negative up here and you have a negative there. What is the result of a negative divided by a negative? Well, this becomes a positive. So now we have our common denominator. We can set it up as A minus B. And all of these are positive, so we can just get rid of our parentheses now. It's all positive. And we just add our like terms. So let's put it in some sort of order here. We have a 3a squared, put that one first, minus 6ab. Now we don't have to reverse any signs because of what we did here. And this becomes plus 3b squared. Now we're going to look and see if anything else can be done to this. Okay, so the first thing we can do to this numerator, I see there is a common 3 that I can factor out, and then I'm left with a perfect square trinomial, which will factor into a binomial squared, which is going to be a minus b, a minus b, and this is all going to be over our common denominator now, a minus b. So what happens? This will cancel with one of these. So our final answer for number 5 is 3 a minus b over 1, which we don't write the 1. So it's just this. Now, you could distribute that, and that would be 3a minus 3b, but this is okay. If you distributed it, that would be okay too. All right? Now let's go on to number 6. Now in number 6, as we look at it, do we have common denominators? No. So we have to make it a common denominator. So I will show you the strategy for this. I'm going to factor this one into its conjugates, x plus y, x minus y. Well, our common denominator then would be this, so x plus y, x minus y. Now this one is lacking an x minus y, so I can just put this up here too, xy. That would be this one here in its factored form, but now it's going to be plus something. So I have to multiply this denominator by x minus y. Now remember, we're allowed to multiply anything by 1. x minus y over x minus y. This is a 1. And now this has my new denominator, and I just have to multiply this. Plus x squared minus xy. Now the big question is, what can you do here? Well, let me work on this. Well, I didn't have to work too much because here I have an xy minus xy. So these are just going to subtract out. So I'm left then for number 6 with x squared over x plus y, x minus y. Or you could have FOILed it and put it that way as well. But again, they like to leave it in factored form. All right, let's work on number 7 now. Now notice this negative sign, which is a little bit of a troubling thing. So what I'm going to do, and again, there's different ways to do it. I'm going to make this a positive here. And I'm going to put the negative there. So I just got rid of that little negative sign that could be a bother. Now what I have to do is figure out what's my common denominator here. Well, we know this is just x plus 1, but when I factor this, this factors into x 3, 1 plus plus. So I have this is there. This term, to get this common denominator, needs to have this there. So I'm going to have to multiply this 3 here by this factor that's missing. So this will be x plus 3, x plus 3. So I'm going to do that. So 3 times x is 3x. 3 times 3 is plus 9. Now this one, remember, I have a negative out in front of that parenthesis. So in order to get rid of that parenthesis, I have to change this. This will become a negative x, and this becomes a positive 2. So I've done everything, hopefully slowly enough for you to catch on as we do it. But now looking at this, I have to group like terms. So I get up here a 2x, just bringing these together, plus 11. And that will be my final answer. I can't really factor anything out of there. Okay. So these were sort of the easy ones, but they showed us the sort of thing you need to have studied and worked on as you did your chapter 6. Let's move it up and we'll look at function, which they like to work with a lot. Now as you do that, they want you to simplify and list all restrictions on the domain. Oh. So lots of things going on here. So let me work that out for you and then we'll go over it in detail. Well, let's get the restrictions out of the way here on the domain. It's what would make any of these denominators a 0. So as we look at the first one, we just take this denominator and equal it to 0. So if you solve that, you get x equals a negative 4. And for this one, which is x minus 2 equals 0, we have x equals 2. And for this one, you have, I'll put it right underneath here, x equals 2 here because we're going to equate each of these to 0. And here is x equals negative 4. Okay, well, interestingly, this and this are the factors of this. So in set builder notation, we're going to say that x is a real number, but x cannot equal a negative 4 or a 2. Because if x were a negative 4 or if x was a 2, it would make these denominators a 0. So those are the restrictions on the domain. X is a real number, but cannot be what would make the denominator a 0. Okay? Now this helps us too in actually doing this. I'm going to erase this part so it gives me some room. And let's get back to that. So it doesn't get too complicated. I've just rewritten this down here. So this is that, this is that. Now notice what I did here. I changed this sign to positive. And I put the negative up here. That's just for strategy. And we said this factored into this. So now, in order to add these all together, we're going to have a common denominator. So what is our least common denominator? Well, it's going to be this and this. So in order to get these to become this one I have to multiply by x minus 2. And remember, this is just a 1 here. And the same here, x plus 4. Okay? Now, all of them have my least common denominator of x plus 4, x minus 2. I just have to do this. So 3x minus 6, x squared plus 4x. And then I had to reverse each of these signs. This is going to be a negative x and a negative 3, negative x squared. Now notice what happens, and I'm going to erase some of this to clean it up here. This is a positive x squared minus x squared. These just cancel out. Now, what do I have left? I have here a 7x as I add a 3x and a 4x together. Then I have a negative 6 and a negative 3, which gives me a negative 9. So that is my answer. 7x minus 9 over this common denominator. And that was what we did for number 8. Okay, number 9 is a little tricky. And you notice that these examples are a little tedious in that They take a long time to do because there's so much going on. Now here what they want you to do is division, but they also want you to find the restrictions of the domain. So we have to look at this one as it is in the denominator of this fraction, which is what I have right here. So we can't have a 3 and we can't have a -4 there. But later this will become the denominator when we actually change it to multiplication. So we also have this one. Well, this is going to be equal to 0. So we can't have a 0 there. And this is going to be a +4. So x then would be any number, but cannot be these four: a 3, a -4, a 0, or a +4. Because in some instances it would make the denominator a 0. And that's how you do it. So you had to find this one, and this one, equal those to 0, and solve them. Now let's do the problem. So this is the difference of perfect squares. Factor it into its conjugates. This one is just this. This we had to use its reciprocal. So when I factored this, we got this. Factored this, we got this. And now we're looking for common factors. So this will cancel with this. And I guess that's about the size of it here. How do you write the answer? Well, you're going to write it as x plus 3, this one. Now we have two of those, so you should write this as x minus 3, the quantity squared, all over 4x minus 4. Wow, lots of stuff going on for just one example. All right, let's go on. Now you may not be doing division of complex fractions here, or simplification of complex fractions, but it's so close to what we've been doing. I'll do these and show you a technique, and if it's not used, well, we'll just skip it over. But the general rule for this, and there's a couple of ways to do these, is just to find out what is your least common denominator of both the numerator and denominator, which happens to be AB. So we put our parenthesis, and we're now going to do the multiplication of the numerator. Now notice the a's will cancel out here, and we're left with 2b. The b cancels out there, and we're left with 5a. And then here the a's cancel out, and we're left with a b. And there's a minus sign there. And then the b's cancel out, and we're left with 4a. So for number 10, there's the answer. So it wasn't too difficult. Now, number 11 gets to be quite a challenge. So I'm assuming you're not going to be doing that, and that would take a little bit of time. So we'll pass number 11 up. Let's go on to number 12. Now, number 12, you're definitely going to have. This is equations that involve rational numbers, that is, fractions. So what would be the strategy for doing this? Well, the strategy would be, in this case, to cross multiply. So it looks like this. I'll write it out for you. And again, these are things you would have worked on in your class during the lectures on these topics. This is sort of a review. So we take the 4 and multiply it by this, get that. Take the 2, multiply it by this, get that. Transpose to both sides, divide both sides by 4. X is equal to 9/2. And you can leave it as a fraction. Now, let's do number 13. All right, to start off number 13, you're going to factor this into that. And interestingly, these are the other two denominators here. And what we want to do when we have this type of equations with fractions in it is to get rid of the fractions by multiplying every term by the greatest common denominator, or the least common denominator, whatever. And it happens to be these two. So that'll be my next step. So I'm going to multiply each term by this common denominator. And notice, this all cancels out here. Here, just the t minus 3 cancels out. And here, just the t plus 4 cancels out. So we're left with our next step. So here, this all cancels out, and now we multiply through. This is t plus 5. This is t plus 4 times 1, which is just t plus 4. I may be missing a parenthesis up in there. And then here it's t times 3 is 3t. Negative 3 times 3 is negative 9. So I group like terms. I get 2t plus 9 equals 3t minus 9. I want to keep my t's positive, so this comes over as a negative 2t, and this comes over as a positive. So I get here 18, and it looks like for number 13, t equals 18. And there are the steps to get to it. Okay. For number 14, we're just going to substitute a negative 1 where the x's are. And this becomes a 3 over negative 2, so a negative 3/2. And here we're just putting a 2 there and a 2 there, and we get 6 over 1, which is 6. Okay, in number 15, they say find all a's for which this function equals 2. So we're going to have to set that up as an equation. So when to think of it, we're saying that this equals 2. So we have this equals 2. And we can think of that as 2 over 1. We're just going to cross multiply. So we get x plus 4 equals 2x minus 2. Just cross multiplying this way. And we bring the x over. That becomes a x then. Bring this over, becomes a positive 2. And for number 15, it's that. Okay, these are getting a little bit long. This is 34 minutes. So what I may be able to do, I think, is terminate this one and then pick up as a part 2. Otherwise, the tapes are going to be too long. So let's close this one out.